Welcome to the world of foam. Foam is everywhere in our daily life. It's in your bed, it's in your car, it's between the walls. Cleaning sponges and cushions are all made from foam. As a beauty material, foam has a lot of specialties that other materials don't have.
To start out with, I'm going to tell you a little history about foam. Dave Sweet is the father of foam. He had always been passionate about surfing. 50 years ago, surfboards were made from wood. He did many experiments to make a surfboard out of foam. After getting kicked out of Navy and his own house, he made foam surfboard in the basement at the right temperature and pressure. And now his surfboards are one of the most respected brands.
There are two different types of foam, open cell and closed cell, which simply means the cells that form foams are either broken or closed. Differences between those types are density and firmness. Density measures the ability to support. Firmness measures the softness. Firmness is independent from density, which means it is possible to have a higher density foam that are soft.
Open cell foam is very flexible and soft in comparison. Since the cells are open, they can absorb more noise than closed cell foam. However, they're weaker in strength. Closed cell foam has greater resistance and denser. Because it requires more material to make closed cell foam, it is also more expensive. Foam is frequently used in model making because it is easy to be cut and shaped. However, very little use of foam plastics has been made in buildings. Besides serving as a roof insulation, their main use is to serve as a core material in sandwich panels, where they only provide the insulation. The University of Michigan did an interesting research on the potential structural value of foam in housing for the developing areas. The most common rigid foams today are polystyrene and polyurethane, which has the greatest potentials to be used in housing. Because of their state of development now, they offer a lot of possibilities in structural construction. At the same time, a large segment of the plastic industry is eager to find new investment to put in their development and production. It is possible to use potential value of plastic foams in housing. Using foam in housing comes with both benefits and disadvantages. As a material, foam has lighter weight than all others. It is easier and cheaper to be made, and there is always a variety of color and shape. On the other hand, foam has lower strength than metal, wood, or concrete. It also has low elasticity and high thermal expansion. A major problem that foam has is their flammability. It can easily catch on fire, and the gas being produced are harmful for people. Thanks to the technology in the 21st century, there are fire-resistant and self-extinguishing foams available. So today, foam as a material can perform in structural applications in housing. The reason that foam will be particularly useful is because how easy it is to produce foam. It only requires some skills and a small amount of people. Foam is even more valuable because it can perform 3 different kinds of application itself. The 3 different applications are primary structural application, secondary structural application, and contributing structural application. As the name suggested, the differences between the 3 applications depend on which material provides the support. In primary structural application, the foam plastics constitute the building elements for the overall stability of a structure. Foam is only used as double curved shell under this application. Double curved shell are highly resistant to collapse because of their doubly curvature. The dome houses in the picture are buildings in Japan, and they are examples of the double curved shell. In the secondary application, plastic foam don't have to provide the structure anymore. By using other materials, wood, metal, or plastic, the range of the application foam is extended to single curved shell, folded plate structure, and sandwich panels. Besides the primary and secondary applications, there are many applications of foam where foams are only doing the form-giving job. Although foam has to be self-supporting until the structure materials take their final set, foam is not supporting the final structure.
For example, foam will support the shape it created, and then we can spray glass over the foam. After glass is set, foam does not support the structure anymore. The glass does. In order to succeed at putting foam into use in developing areas, there are more steps to be followed. First of all, the production of plastic foams need to be monitored by chemical engineers. Even though experiments with foam are promising so far, there should be more experiments to follow up. Then, when it comes to design and physically make the building, they should work with professional architects. Once a building type is accepted by the public, it is also important to make sure the country has the ability to reproduce those houses. To sum up all the information, foam started as a surfboard material. There are two different types of foam, open cell and closed cell. They each have their own properties and usage. Common usage foams so far are model making and sandwich panels in buildings. However, there is a research proof that foam has a big potential value in housing, especially in developing areas with the help of technology today. There are three different kinds of application that foam can perform itself. With effective follow-up helps and enough aids to the countries in need, it is a highly possible plan. If you have any questions and suggestions, please leave a comment under the video. Thank you